SABS as a company was started in 2004. I'd like to share with you the secret of SABS name, and as we reflect back 13-14 years, SABS stands for Strategies for Advanced Building Solutions. So what was visualized that long back is coming to fruition today. As part of this, in 2007 or thereabouts, we came across BIM as a very powerful tool. Now, BIM, what it does actually, BIM, because you are essentially delivering the project twice, once in the virtual mode and once, of course, during the final construction, all the clashes, all this, the unpredictability, of coming across something, during construction and then sort of having to stop, And on big projects, that can mean a lot of money lost. It can mean serious contractual escalations. It can mean delays, etc., etc. So as projects got more bigger, they got more complex, we thought of applying BIM. Another aspect of, I would say reason of bringing BIM was, in the olden days, buildings were mostly orthogonal, which means they were essentially cubes or cuboids. Buildings, they, architects were aspiring all the time to have, free forms or more natural forms, into the buildings. Now, how do you deliver that? But defining a free geometry is not easy. So with BIM tools, this is becoming better. Also to maintain the database, or the information throughout the life cycle of the project. That's very important. So that was the third area. So with all of that, we started implementing BIM from 2007 onwards, and now we have fully migrated into BIM, and we are getting very good results. In the initial tenders, what I'd like to share with you is that we encourage our clients to, in fact, build into the consultancy contract a training component. So after or while we are delivering the project using BIM, we also in parallel train the staff or the client staff.
So this was in the year 2009. So we started with the Children's Mall. The Children's Mall was at Doha, Qatar. So the client had got a great looking design done basically, and he was looking for someone to deliver the GFC package. The design was based on a box supported on a single corner, and there were no verticals in the design. All the walls and the columns were sloping, and there was nothing in plumb. So when we got into this project, we decided to use a mix of Revit and AutoCAD to deliver this project. Initially, we started to model the basic structure and the architectural skin of the building in Revit. Then we added the floor slabs, staircases and the cores. But what we feel now, if we get this project now, or with the current features of Revit, it would have been a real cakewalk doing this kind of project with Revit. So now the project is under construction, it's almost finished, and we still get RFIs because there are a lot of clashes between the MEPs and all. But still, thanks to Revit, we were able to deliver this.
Currently, we are working on a number of stadiums for the FIFA 2022 to be organized in Qatar, and BIM has found many applications there. In particular, of interest, which I'd like to share with you is what we call sightline analysis. Now, FIFA has got very stringent requirement for each seats. Now, from each seat, the spectator must be able to see four corners of the pitch, the goal posts, and a few, there are other associated requirements, I would say. So, to manually, visualize each seat and draw the sight line from each seat is practically impossible. Now, how to do that? So, we thought of applying BIM. Now, each spectator, was modeled as a sphere, if you will. His face, was modeled as a sphere, and from that we sort of set in the parameters, which we call the C view from FIFA, which means the vertical distance, which each spectator must achieve on top of the preceding spectator, correct? And then, of course, you stagger the seats as well. So this is modeled in BIM, the parameters, and finally the end result we get in terms of a pixelated image. Now, seats which are passing the full requirement of FIFA, they are pixelated, say dark green, then lighter green, then shades of yellow, and then finally which are sort of not acceptable are in orange or red. The stadium projects which have been rolled out in Qatar currently, these are 8 new stadiums been built from scratch, all at the cutting edge of technology. All the stadiums are air conditioned. This has not been done before anywhere in the world, so all of them are using BIM.
Al Grafa Sports Club is a Qatari sports club located in Al Rayyan Grafa district of Al Rayyan, Doha. The current stadium, which is the home ground of Al Grafa Sports Club, was built in 2003 with the seating capacity of 22,000. It has been decided to upgrade the Grafa Stadium as per the international FIFA standards. So initially we developed the LOD 200 model of the existing stadium with the help of as-built drawings. The BIM model was extremely useful for us to visualize the basic concept form, and the design decision was taken during the concept design. To maintain the temperature below 26 degrees on the field and the grandstand area, the use of outdoor cooling was mandatory for us. Maintain the ambience air temperature while allowing adequate sunlight was the challenge to overcome while keeping the structure as light as possible. Revit came handy for us to perform solar study reports, which helps us to maintain the FIFA guidelines for our usage of natural turf. The use of virtual construction through the BIM model results in enormous time saving since the deadlines of the project in the FIFA World Cup is very close, that's 2022.
Clash detection is an important and integral part for the BIM modeling process. Clash detection occurs when the different elements of different model can occupy the same space in a model. It can be between the HVAC model and architecture model, or also it can be in between structure versus architecture model. Model is done for the clash detection through software called Naviswork. All the clashes are identified and eliminated before the actual construction starts. This is done provides us lot of benefits like saving unnecessary cost, manpower, and most important, time.